In this video, we're going to discuss how to find symmetries on a graph. Okay, so we want to be able to answer this question. Test the equation for the symmetry with respect to the x-axis, the y-axis, and the origin. So before I do that, I need to discuss with you what, how to find, how to do this test. How do I know if an equation is symmetric with respect to x, y, or the origin? So first, let's talk about symmetry with respect to the y-axis, okay? So let's first talk about symmetric. So this WRT, that means with respect to the y-axis, okay? So think of it like this. If we were able to, so say I have this here. Okay, this is symmetric with respect to the y-axis. And this graph I'm trying to graph here is y equals x squared. And the reason that this is symmetric is to see if I were to fold this over here. Maybe my drawing's not perfect, but the idea is that if I were able to fold it over there, then these two lines would line up on each other. Okay, so it's symmetric around the y-axis. Alright, so how would I be able to test that this is true? Well, if you see here, so say here at 2, well, if x is 2, what is y? Look at this equation over here. If x is 2, y is 4, right? So here's 4. And then if x is negative 2, y is still 4, right? Because negative 2 squared is still 4. So the way you test if you have a symmetry amongst the y-axis is that you plug in, well, x is already there, so then you plug in negative x, the negative version. So in this case we would have y equals negative x squared, and then you see if this is the same as with just x. Okay, so you plug in negative x, and then if you see if the negative basically goes away, and then you're at, like this is the same as this. Okay, why? Because the negative canceled when you squared it. So let's do this. Let's talk now about symmetry, symmetric with respect to the x-axis. Alright, so with respect to the x-axis, so basically you can just think of this, let's just flip it. Say we had this here, okay, and this would be y equals x, oops, well actually y squared equals x, okay, so y squared equals x. So this is, if we were to now, we would have to, instead of plugging in negative x, we're going to plug in negative y. So I'll go ahead and, looking at this equation, so y squared equals x, I'm going to plug in negative y. So negative y squared equals x. Now, the negative cancels, so negative y squared is the same thing as y squared equals x. So because these two match, the original and then also the one where negative y was plugged in, this is symmetric amongst the x-axis. Alright, lastly, let's talk about symmetry with respect to the origin. Do that over here. So, 3, let's talk about symmetric with respect to the origin. Okay, and so, for example, a graph that's symmetric with respect to the origin would look like this. Okay? And the reason why you know that this is symmetric about the origin is to say you were to fold it first this way, right? And then you would end up with that line coming down here. And then you were to fold it this way. Now the two lines would line up on each other and they would be here. Okay? So that's how you can tell if it's symmetric around the origin. Now, just by looking at it. So if you fold it both amongst the y and then the x, or the x and then the y, then they would line up on each other. Okay, so let me go ahead and delete this so it's not so messy. Okay, so this is what our graph looks like. So this is the graph for y equals x to the third. Okay, so when we said symmetric around the y-axis, we plugged in negative x. We said symmetric around the x-axis, we tested it by plugging in negative y. So for this one, we're actually going to plug in both negative x and negative y. Negative x and negative y. So let's do that. So if I were to plug in negative x and negative y, I would have negative y equals negative x to the third power. Okay? So something to the third power is still negative, right? Because the negative doesn't get canceled out when you put it up to an odd power. So this would be negative y equals negative x to the third power. Then if I were to divide both sides by negative 1, I would then get, I'm going to move this, okay? I would then get y equals x to the third, okay, which matches the original equation. So we can see that this is indeed a graph that is symmetric around the origin. Okay, so now let's take these tools that we just learned and let's answer this question up top here. Okay, so let's see. First, let's go ahead and do the test for symmetry with respect to the x-axis. So let's start with respect to the x-axis. Okay, so remember I said what you do when you're trying to find test for symmetry with respect to the x-axis, you plug in y equals negative y. Okay, so I'm going to plug in negative y, and I'll get x to the fourth minus 3x squared minus 2 divided by x squared. Okay, if I were to solve this for y, I would get y equals negative, and x to the fourth minus 3x squared minus 2, okay, that divided by x squared. Alright, this is not the same thing as what we have up top, okay, because this negative sign's there, and there's no way for it to go away. So, this is not the same thing, so we are not symmetric with respect to the x-axis here. Alright, so now let's do the test with respect to y. With respect to the y-axis. Okay, so to do this, you're going to plug in x equals negative x. Okay, so I have y equals negative x to the fourth power plus 3 times negative x to the second power minus 2 divided by negative x to the second power. Now, notice that, so negative x to the fourth power, the negative sign goes away because it doesn't matter if it's negative, it's to the fourth power. So, anything to a fourth power is going to be positive. So it's the same thing as x to the fourth plus, same deal goes when you have negative x squared minus 2 divided by x squared. So you have y equals this here, and that is exactly what you see up top. So this is symmetric with respect to the it is symmetric with respect to the y-axis. This is symmetric with respect to the y-axis. Alright. Okay, lastly, let's test the symmetry with respect to the origin. So remember, to test symmetry with respect to the origin, we're going to need to plug in x equals negative x and y equals negative y. We're going to check it out. So if we do that, we'll have negative y equals, so we're going to plug in negative x, x to the fourth plus 3 negative x squared minus 2 divided by negative x squared. Okay, so the negative stays, now these negatives are going to cancel because it's to an even power, x squared. So now if I were to divide both sides by negative 1 to solve for y, I would get negative x to the fourth plus 3x squared minus 2 divided by x squared. So notice this is not the same as what we have up here, so these two y's are not equal, so this is not symmetric with respect to the origin. not symmetric with respect to the origin. So the only symmetry that was in this equation was, it is symmetric with respect to the y-axis, and that's it.